This basically depends on the optical density. Again, it's the same thing. How speed is varying in a different medium is understood by optical density. It's not as the normal density which we have learned. Optical density is slightly different thing. So if I see that over here, you can see that this is a air, this white color material, we have a air, and air has refractive index as 1. That is what it is given over here. And the other medium which we have, that is the water, and which has a refractive index as 1.33. So when light travels from air to water, it will bend towards the normal. So when light goes from a lower refractive index to higher refractive index, then light will bend towards the normal. Now, if I change this medium from air to water, then there will not be happening any bending. Why? Because light is still at the same medium. There is no two media present. But if I convert again, change it to water to glass. So when light is traveling from a higher refractive index to lower refractive index, or I can say when light travels from a denser medium to rarer medium, then light will bend away from the normal. So which you can see over here. At any different angle, light will always be bending away from the normal. Now, coming to next thing, which we called as the dispersion of light. So if I take a prism over here, if I take a prism over here and I start this laser of a red color light, then you can see that there are two type of refraction happening over here, like refraction at this surface one and refraction at this surface. So again, two bending is happening. Now, if you change this red color to another color, let's say green or red or blue or yellow, okay, so then also these refractions will happen. But we all know the light which is coming from sun is not a red color light. It's not a orange color light. It is a white light. So the light that comes from sun, that is a white light. So inside that white light, we have all these seven different colors, whether violet or red or green or orange or so on. So when a white light passes through that prism, it will disperse. Okay, it will be dispersed into a seven different color. So white light passes through prism, it will disperse in seven different color, and that is what we called as the dispersion of light. So splitting of white light in seven different color, we called as the dispersion of light. Now, if you see the color which is on top will least refract, and the color which is at bottom will refract maximum. So the color which is on top will have maximum wavelength. So the color that is a red color will have maximum wavelength and it will have the least frequency. And if I go down, the violet color or purple color will have maximum frequency and the least wavelength. Higher frequency is very much proportional to the higher energy or higher ionization. So we generally do not like the color which has a higher energy and higher ionization. That we can understand that we generally do not like that higher energy and higher ionization by electromagnetic spectrum. So what is a electromagnetic spectrum? So you must have seen that there are radio waves, microwave, visible region, the colors which we can see. So that comes under the visible region, infrared region, X-rays, gamma rays, and so on. So all that type of waves which we called where all different type of waves are present based on the different wavelength, we call as electromagnetic spectrum. So the left hand side we have radio and microwave. These region have a greater wavelength. On right hand side of electromagnetic spectrum, we have basically X-ray and these type of waves, gamma rays and all, which has lower wavelength. Lower wavelength means greater frequency and greater energy. So you must have learned that greater energy are not good for us. So radio waves which are in our surrounding, we are okay with it. We listen FM and everything. So communication purpose, we do use radio waves. Even microwave, we are using a lot in our kitchen. So that is also not very much harmful. But X-ray, gamma rays are not good for us since they have greater frequency and greater energy. If you have visited doctor, then if you have done X-ray any time once in your life, they always says that you should do X-ray once in a 3 month or 6 month. Regularly moving to that room is not good for us. That causes the mutation or cancer and all those things, right? They can damage your cell. There is a one more type of radiation which we call as a infrared radiation, which we use for small sensor or communication only. If you have seen any remote control, either of TV or some other device or a AC or a fan, then you must have seen a light on top of it. Now to start with, the very first thing that which we called as the total internal reflection. So what exactly a total internal reflection is? Let's try to understand. So what I was doing is I clearly understood what is a refraction of light. So we have a normal and two different surfaces. This surface I am calling refractive index as N1. This surface has refractive index N2. And this N1 is less than N2 or N2 greater than N1. That means whenever light will travel from one media to another media, light will bend away from the normal. Now what happened that I am increasing this angle of incidence. So if I increase this angle of incidence, light will further bend away. So what exactly critical angle is? This is angle of incidence for which angle of refraction is 90 degree. So how will I define critical angle? Critical angle is angle of incidence for which angle of refraction would be 90 degree. So if you further try to increase the angle that is greater than critical angle, light will come back to its own medium. This particular thing or this particular phenomena we called as the total internal reflection. So for TIR to happen, we have only two conditions. Number one, angle of incidence should be greater than critical angle and light should travel from denser to rarer medium. So what exactly TIR is? When light travels from one media to another media, it bounces back to the same medium. This particular thing we call as the total internal reflection, and conditions would be angle of incidence greater than critical angle and light should travel from denser to rarer medium. So if you see the theoretical definition, so light completion of reflection, light back into the same medium for angle of incidence greater than the critical angle of the medium. Angle, the incident ray must be in denser medium to rarer medium. It should go like that. And angle of incidence should be greater than the critical angle. And how do we define critical angle? This is angle of incidence for which angle of reflection would be 90 degree. Some of the application of TIR, if I see, that is which we use a lot in case of optical fiber. So what exactly optical fiber is? That the internet cable through which our internet is coming, or basically the high speed internet, that's because of optical fiber. So in case of optical fiber, it's a fiber and we have a something which we call as a cladding on the outer surface of optical fiber. When a light strikes to this surface, then TIR takes place because of the cladding. We keep a denser medium over here and the angle of incidence is like that. Then light will reflect back and it will be like that, it will be like that, it will be like that, and it will be like that. Because of that, my signals travels very fast inside the cable and I get the piece of information very quickly. And hence, the speed of internet which is desired for us gets increased. So you must have seen that the technology after which sudden peak in a speed of internet, like so that's all because of the optical fiber. So the light can travel very fast. Even in medical purpose, like endoscopy, something which we call is used also as a very similar technology of total internal reflection. These are the use cases. Some of the phenomenon which you must have observed in day-to-day life, that is also because of TIR. Let's say you are traveling on a plain road and we observe that at a certain distance there is a water. And the moment we reach to that distance, we find there is no water. And it continuously happens inside the car that we feel that, oh, lot of water is there on the road after some distance, but there is no water at all. And that is also because of the total internal reflection. The lights coming from sun reflect back to our eyes. It looks that there is a water. And looming is also one thing which we see, that is also because of TIR, where inside the sea we find that some of small ships and all like little bit above from the surface of the sea level. So that is also because of the it's an like reflection phenomenon only. I want you to draw this picture down and so that critical angle condition for TIR will get clear to you. These are some of the use case of total internal reflection in case of prism also and optical fiber. Now we'll try to see what is a spherical refracting surface. So spherical refracting surface is nothing but one side of the surface we keep as a rarer medium and other side of surface we keep as a denser medium. And there are two type of these surface. One is a convex refracting surface and concave refracting surface. In case of convex refracting surface, it is bulbs outside, and in case of concave refracting surface, there will be a cave looking shape from the outside. So it looks like this. This would be a convex one and this will be a concave one. If you can see that the point that divides the refracting surface in two equal half that we call as the pole, center of curvature is a center of the sphere, bigger sphere of which the refracting surface is part of. If you join a line from P to C and everything, that line we call as the principal axis. Half of that would be the focus and all. Objects are generally always on left hand side. We assume that distance is negative and incident rays make small angles, very small angles and paraxial rays with respect to principal axis. So we are doing a derivation. In that derivation, these things will be useful. What exactly a aperture is? Aperture is size of that refracting surface. That also we keep very small. So considering with these three assumptions, let's try to derive a formula that can help us to know what would be the position of image and object. So number one is we called as the ray of incidence goes like this. After refraction at this surface, this would be normal. It will bend towards the normal since it's a denser medium and it will go like this. So this angle we called as alpha formed by incident ray and the principal axis. This angle I am calling as beta, that is the angle formed by the refracted ray and the principal axis. If you extend the normal and cut a certain point on a principal axis, and that makes an angle which we call as the gamma. And then later on, I will join this line A to M, and M and P are almost same. This assumption I will take later on that P and M are exactly same. So that is how my refracting surface and these all angles will look like. Now, if you see angle of incidence I is equal to alpha plus gamma. So where exactly angle of incidence I? Alpha is this angle, gamma is this angle, and angle of incidence I is this. If you could recall grade 9 mathematics, you must have heard that sum of opposite interior angle is equal to exterior angle. That is what they are using over here, that I is equal to alpha plus gamma, since this is an exterior angle is equal to sum of opposite interior angle. Don't ask for proof. I can prove also. And then same way, gamma can be written as for this small triangle ACR plus beta. If I do 10 alpha, that will become MO by MO. 10 beta will be MA by MI and 10 gamma will be this. Since in assumption I have already taken guys that angles are very small. When angles are very small, I can take 10 alpha is equal to sine alpha and this is equal to alpha. So these 10 alpha is reduced to alpha, 10 beta by beta and 10 gamma by gamma. Now Snell's law is what? Sin I by sin R is equal to mu 2 by mu 1. So I can write I by R is equal to mu 2 by mu 1. So mu 1 I is equal to mu 2 R, mu 1 and this. Now if you replace M by P, wherever M is written, you can write PC, PA, MA and all. And the PO will be the object distance, so minus U. PI will become V, image distance, and PC will become R, since this is the radius of curvature. Substitute the values accordingly and check whether we can get this relationship or not.